Dear students, in the last class we discussed on the topic photoelectric effect and the experimental setup used to verify that photoelectric effect and also the experimental observations. These things we discussed in the last class. Today I am going to discuss on the topic Einstein's photoelectric equation. The theoretical explanation for the experimental observations was given by Einstein. Einstein used Planck's quantum theory to explain the experimental observations of photoelectric effect. And we studied about Planck's quantum theory. According to Planck's quantum theory, a radiation consists of photons. Photons are nothing but energy packets. Photons are also called as quanta. So, using this quantum theory, Einstein gave an equation for photoelectric effect. Here, he applied Planck's quantum theory. Whenever a radiation is incident on the metal surface, that radiation consists of photons. Each photon carries an amount of energy, h nu. That incident photon transfers its entire energy to the electron in the metal surface. Electron absorbs that energy. Out of the total incident energy, a part is used as the work function of the metal. A part is used to overcome the work function, that is just to eject the electron from the surface. Remaining part of the energy comes out in the form of kinetic energy of the electron. And using this idea, see there, maximum kinetic energy of the photon, that depends on energy of the photon, incident radiation, that's the energy of the photon, as well as the work function of the metal. Therefore, if the work function is more, then maximum kinetic energy will be less. So then he gave the equation maximum kinetic energy of the photon equal to energy of the photon minus the work function. Kinetic energy maximum equal to h nu minus phi. H nu energy of the photon, phi the work function. So that kinetic energy is nothing but half m v maximum squared, where v maximum velocity of the electron moving towards the anode plate equal to h nu minus phi. Or from this we get h nu as phi plus half m v maximum square, but the work function of the metal is given by h nu naught. H Planck's constant, nu naught threshold frequency of the radiation, so that h nu is h nu naught plus half m v maximum square, or the maximum kinetic energy is given by the formula h into nu minus v naught, and this equation is called Einstein's photoelectric equation. Using this, he derived this equation by applying Planck's quantum theory, and using this equation, this theory, Einstein's theory, would explain the experimentally observed facts. The experimentally observed facts were the process is instantaneous, the incident radiation should possess a minimum frequency called threshold frequency, then only there will be photo emission, otherwise there is no photo emission. The photoelectric current depends on, it is directly proportional to the intensity of the radiation. Kinetic energy depends on the frequency of the incident radiation, and also there is a potential called stopping potential to stop the electrons completely reaching the anode plate. There, depending on the stopping potential, the electrons will have the maximum kinetic energy. These are the experimentally observed facts, and these are explained using the equation. Or now let us see how these observations are explained. Let me consider the first one, process instantaneous. This observation is explained by Einstein using this equation as, see here, both electron and photon, both are the microparticles, and when they collide with each other, whenever the photon falls on the electron, both are microparticles, so that there is no time lag, or that emission of the electron is so fast that there is no time lag in incidence and emission. That's why the process is instantaneous. The second observation is the incident radiation should possess a minimum frequency called the threshold frequency. Otherwise, there is no photo emission. Let us see how this equation explains that threshold frequency. So this is Einstein's photoelectric equation. Suppose the incident radiation has got frequency less than the threshold frequency, say. If mu is less than mu naught, then as per this equation, half this maximum kinetic energy, that becomes negative. But kinetic energy cannot be negative, it should be positive always. Therefore, if we take maximum kinetic energy positive, it is greater than or equal to 0. It may be positive or it may be 0. If the frequency is exactly equal to the threshold frequency, kinetic energy may be 0. So that when this is greater than or equal to 0, that implies this is greater than or equal to 0, or from this we get mu should be greater than or equal to 0. Mu should be greater than or equal to mu naught. Then only there will be photoemission. This is how the threshold frequency is explained using this Einstein equation. The third observation is dependence of kinetic energy, maximum kinetic energy, on the frequency of the incident radiation. Again, let us take Einstein's equation. Here we use a certain metal, there is photoemission. That metal, it has got its own work function. So for a given metal, work function phi is a constant. Then if the frequency of the incident radiation is increased, as mu increases, what happens? Naturally, this maximum kinetic energy increases. This is how increase of maximum kinetic energy or dependence of maximum kinetic energy on frequency is explained by this equation. And one more observation is dependence of current on intensity of the radiation. Dependence of photoelectric current on the intensity of the radiation. See here, intensity of radiation. As intensity increases, there is increase in the photoelectric current also. This was the observation. As intensity of the radiation increases, increase in intensity means there will be increase in the number of photons. Number of photons more means the radiation is more intense. More number of photons means, see here, the collision between the photon and the electron is 1-to-1 collision. One photon ejects only one electron. So that number of photon increases means number of electrons also increases. As number of electrons increases, there will be increase in the photoelectric current. This is how the dependence of photoelectric current on intensity is explained using this equation. And this is the explanation given by Einstein to the experimentally observed facts using this equation. And the equation is kinetic energy maximum is equal to h into mu minus mu naught. What is h? It is Planck's constant. So with this, I stop here. Let us continue the next class with another new topic. It is Compton effect. Thank you.